At the heart of the Pringles production process lies a transformation that completely redefines how potato snacks are made. Unlike traditional potato chips, which rely on slicing whole potatoes and accepting natural variation, Pringles are built on a philosophy of total control. Every crisp begins its life not as a slice, but as a carefully engineered potato-based dough. This transformation, from raw potatoes to a perfectly uniform dough, is the foundation that makes identical shape, texture, and taste possible on a global scale. The journey starts at the farm. Potatoes grown for Pringles are not random varieties pulled from open markets. They are specifically selected for their starch content, low sugar levels, and predictable behavior during cooking and drying. Too much sugar would cause excessive browning during frying, while inconsistent starch levels would affect texture. Farmers work under strict agricultural guidelines, ensuring the potatoes meet exact standards long before they ever reach the factory. When truckloads of potatoes arrive at the processing facility, the first step is inspection and sorting. Automated systems and human quality teams check for size consistency, external damage, rot, and foreign materials. Any potatoes that fail to meet standards are removed immediately. This early filtering ensures that only high-quality raw material enters the production stream, reducing waste and improving consistency downstream. Once approved, the potatoes move into industrial washing systems. These machines use high-pressure water jets and rotating drums to remove soil, stumps, and debris collected during harvesting. Cleanliness at this stage is critical. Even microscopic dirt particles could affect the final product's texture or interfere with later mechanical processes. The washing phase also includes water recycling systems, where filtered water is reused to minimize environmental impact. After washing comes peeling. In large-scale food factories, peeling is often done using steam peelers or abrasive systems. Steam peeling briefly exposes potatoes to high-pressure steam, loosening the skin so they can be easily removed without damaging the flesh underneath. This method preserves the maximum amount of usable potato while maintaining smooth surfaces. The removed skins are not wasted. They are often collected and repurposed as animal feed or used in bioenergy production. With skins removed, the potatoes are now ready for cooking. Cooking serves several crucial purposes. First, it softens the potato tissue, making it easier to process. Second, it gelatinizes the starch, a chemical transformation that stabilizes the potato's internal structure. This step ensures that when the potatoes are later dried and ground into flakes, the starch behaves predictably during rehydration. Cooking is carefully controlled for time and temperature. Overcooking could degrade starch quality, while undercooking would lead to uneven drying. Once cooked, the potatoes enter the dehydration phase. This is where the Pringles process truly separates itself from traditional chip manufacturing. Instead of slicing and frying fresh potatoes, the cooked potatoes are dried to remove most of their moisture. Large drying systems use controlled airflow and heat to slowly evaporate water without burning or damaging the potato solids. The result is a dry, flaky material that can be stored, transported internally, and used on demand. These dried potatoes are then milled into fine potato flakes. The flakes are engineered to a precise particle size. Too coarse, and the dough would be rough and uneven. Too fine, and the dough could become sticky or difficult to handle. The particle size affects everything, from how the dough absorbs water to how it behaves during rolling and frying. This is why milling equipment is calibrated with extreme precision and constantly monitored. One of the biggest advantages of using potato flakes is stability. Fresh potatoes vary from season to season, farm to farm, and even field to field. By converting potatoes into flakes, the factory creates a standardized ingredient with consistent moisture and starch levels. These flakes can be stored in silos under controlled conditions, ensuring a reliable supply regardless of agricultural fluctuations. This stability is essential for producing the same crisp in every country, every day of the year. The next stage is dough formulation. Potato flakes are blended with water and small amounts of other ingredients, such as corn flour, rice flour, and emulsifiers. Each ingredient has a specific role. Water rehydrates the flakes, bringing them back to a workable state. Corn and rice flours adjust texture and strength, helping the dough hold its shape during rolling and frying. Emulsifiers improve consistency, ensuring fats and water distribute evenly throughout the dough. Industrial mixers handle this process continuously. Massive rotating paddle lecture until it becomes a smooth, elastic dough. Sensors monitor moisture levels, temperature, and mixing time in real time. If the dough is too dry, it could crack during shaping. If it is too wet, It might stick to rollers or absorb too much oil during frying. Achieving the perfect balance is both a science and an art, refined through decades of research and testing. This dough making stage is where natural variation is fully eliminated. Unlike whole potato chips, where each slice behaves differently depending on the potato it came from, Pringles dough behaves the same every time. It spreads evenly, cuts cleanly, and cooks uniformly. This predictability allows the factory to run at extremely high speeds while maintaining quality. Food safety is also tightly controlled throughout this transformation. The cooking and drying stages significantly reduce microbial activity, while enclosed systems prevent contamination. The dough never touches human hands. Everything is automated and sanitized. Regular quality checks ensure that moisture levels, particle size, and ingredient ratios remain within strict limits. Another critical aspect of this process is waste reduction. Because potatoes are converted into flakes and then dough, nearly the entire potato is used. Unlike traditional chip production, where irregular slices or damaged chips may be discarded, the flake-based system allows material to be reprocessed efficiently. This makes the operation not only more consistent, but also more sustainable. From an engineering perspective, this transformation sets the stage for everything that follows. The iconic shape, the perfect stack, and the uniform crunch all depend on the quality of the dough created here. If the dough is flawless, the rest of the process flows smoothly. If it is not, even most advanced machinery cannot compensate. In many ways, this stage represents the philosophy behind Pringles as a product. They are not simply potato chips, they are a designed food, built from the ground up with precision. The transformation from raw potatoes to uniform dough is where agriculture meets chemistry, and where food tradition meets industrial innovation. By the time the dough leaves this stage, it no longer resembles a natural farm product. Instead, it has become a standardized, predictable material ready for shaping into one of the most recognizable snacks in the world. Every crisp that follows, every curve, every crunch owes its consistency to this meticulous transformation. This is why key point 1 is so essential. Without this precise conversion from raw potatoes into controlled dough, the rest of the Pringles process would not be possible. It is the invisible backbone of the entire production line, quietly ensuring that when someone opens a can anywhere on Earth, the crisps inside are exactly as expected, every single time. Once the perfectly engineered dough is created, the Pringles production process enters its most visually striking and technologically impressive phase. This is where an unremarkable sheet of potato-based dough is transformed into one of the most recognizable snack foods in the world. Shaping, frying, and stacking are not just mechanical steps. They are a carefully synchronized system where physics, engineering, and automation work together at extraordinary speed and precision. The journey begins with dough sheeting. The uniform dough moves from mixers directly into rolling machines and quickly into multiple precision rollers. These rollers gradually flatten the dough into an ultra-thin, continuous sheet. The thickness of this sheet is measured in fractions of a millimeter and is monitored constantly by sensors. Thickness consistency is critical. A sheet that is even slightly thicker in one area would fry differently, altering texture and crunch. Too thin, and the crisp could become fragile and prone to breakage. This rolling process is smooth, continuous, and relentless. The dough never stops moving. Conveyor belts guide the sheet forward at a perfectly controlled speed, ensuring that every square centimeter of dough experiences the same pressure and treatment. This step highlights one of the core advantages of the Pringles system: predictability. Because the dough behaves identically every time, machines can operate at high speed without sacrificing quality. Next comes cutting. Mechanical cutters punch oval shapes from the dough sheet in a precise, rhythmic motion. These ovals are not random. Their dimensions are mathematically optimized to create the final iconic shape after molding and frying. The cutting process produces almost no waste. Any excess dough between the ovals is immediately collected, recycled, and fed back into the system, maintaining efficiency and reducing material loss. At this stage, the ovals are still flat and flexible. Their transformation into the iconic saddle shape happens in the molding phase. Each oval is gently placed onto a curved mold, often described as saddle-shaped or hyperbolic paraboloid. This shape is not just visually distinctive, it has functional advantages. The curve increases structural strength, allowing the crisp to be thin yet resistant to breaking. It also creates a unique mouthfeel and crunch pattern when eaten. The molding process must be perfectly timed. The dough ovals are positioned onto the molds just moments before entering the fryer. If placed too early, they could stretch or deform. If placed too late, they might not settle properly into the curve. Robotic placement systems ensure that every oval lands correctly, aligned and centered on its mold. The frying stage is where the transformation becomes irreversible. The molded dough enters a high-temperature oil bath, where it is cooked for only a few seconds. This brief exposure is enough to evaporate moisture rapidly, set the starch structure, and lock the crisp into its final shape. Temperature control here is absolute. Oil that is too hot would burn the surface before the interior cooks. Oil that is too cool would result in greasy, undercooked crisps. Advanced fryers maintain stable temperatures across the entire cooking zone. Sensors monitor oil quality, temperature, and circulation continuously. The oil itself is filtered and refreshed to maintain purity and flavor neutrality. This ensures that the crisps develop their clean, consistent taste without unwanted off flavors. As moisture escapes during frying, tiny bubbles form on the surface of the crisp. These microstructures contribute to the final texture, the lightness, the snap, and the way the crisp fractures when bitten. What seems like a simple crunch is actually the result of controlled dehydration and starch chemistry happening in seconds. After frying, the crisps exit the oil bath and move into a de-oiling and cooling phase. Excess oil is removed using spinning drums, airflow systems, or vibrating conveyors. This step is crucial for both taste and shelf life. Too much residual oil would make the crisps heavy and greasy, while too little could affect flavor delivery. Cooling stabilizes the structure, ensuring the crisp remains rigid and stackable. Once cooled, the crisps enter the seasoning stage. Fine seasoning powders are applied while the crisps are still slightly warm, allowing flavors to adhere evenly. Rotating drums tumble the crisps gently as seasoning is distributed. The motion is carefully controlled to avoid breakage while ensuring full coverage. Laser and weight-based systems measure seasoning levels in real time, adjusting application rates to maintain consistency. This is where flavor identity is created. Whether original, sour cream and onion, barbecue, or cheese, each seasoning blend is formulated to rack perfectly with the crisp surface. The curvature of the crisp actually helps distribute flavor, as seasoning settles into the contours rather than falling away. After seasoning, the crisps move into one of the most iconic stages of the entire process: alignment and stacking. This stage is a marvel of automation. Optical scanners inspect each crisp, checking shape, size, and integrity. Any crisps that are broken or misshapen are automatically removed. Only near-perfect crisps continue forward. Mechanical guides and gravity-assisted channels then orient the crisps in the same direction. One by one, they slide into neat, uniform stacks. Each crisp nests into the next, following the exact curve of the mold that shaped it. This stacking process is not just visually satisfying. It is essential for packaging efficiency. The nested stacks minimize movement inside the can, reducing breakage during transport. The precision required here is extraordinary. A misaligned crisp could disrupt the entire stack. To prevent this, the system constantly adjusts, responding in milliseconds to changes in crisp flow. This is industrial choreography at its finest, hundreds of crisps per minute, moving in perfect synchronization. Once stacked, the crisps are transferred into cylindrical cans. These cans are designed specifically for the stacked format, with rigid walls and foil-lined interiors that protect freshness. A metal base is sealed to the bottom of each can before the stack is inserted. The stack slides in smoothly, guided by mechanical arms that prevent tipping or compression. After insertion, a foil seal is applied to the top, followed by the familiar plastic lid. The can is now airtight, protecting the crisps from moisture, oxygen, and physical damage. Each can is weighed in shore accuracy and coated with production information for traceability. Quality control continues right up to the end. Cameras inspect labels, seals, and can integrity. Any deviation triggers automatic removal. Only cans that meet every specification move forward to packaging. What makes this entire shaping, frying, and stacking process so remarkable is its consistency at scale. Millions of crisps are produced every day, yet each one is nearly identical to the last. This level of uniformity is not accidental. It is the result of decades of engineering refinement and process optimization by Pringles. From an engineering perspective, this stage represents the triumph of controlled design over natural variation. Potatoes are inherently unpredictable, but through shaping, frying, and stacking, that unpredictability is completely neutralized. The result is the snack that looks, tastes, and feels the same whether it is eaten in Asia, Europe, or the Americas. From a consumer perspective, this is what creates trust. When someone opens a can, They know exactly what to expect: the same curve, the same crunch, the same flavor. That reliability is not just a branding achievement, it is a manufacturing one. In the end, Key Point 2 shows how advanced machinery, precise temperature control, optical scanning, and robotic stacking transform simple dough into an iconic product. It is the stage where identity is locked in, where the crisp becomes unmistakably Pringles. Every stack inside every can is a quiet demonstration of industrial precision, proving that even something as playful as a potato crisp can be the result of serious science and engineering.